Welcome to another tutorial for Isogenic Engine, and in this tutorial we're going to discuss how to create an isometric object on screen. At first it might not appear too intuitive, but hopefully by the end of the video you will have an idea of how to do that. So I'm going to go ahead and create a new tutorial, and it's going to be based upon the blank underscore game project, which I explained on how to use in tutorial 2. So I'm going to go ahead and create a new project here called the tutorial 4. And I'm just going to go into my IGE folder, which is under my tutorials, grab the blank game, come back out into tutorial 4. I want to grab the files that are in the blank game folder. Go to tutorial 4, I'm going to paste them in there, and then we go back to here. Alright, so here's our blank game. So I'm just going to quickly make sure that that's been set up correctly. I'm going to fire up my browser here. You can't see it happening, it's off screen for the moment, but I'm just going to bring that over. Hold on 1 second. Right, here we go. And here's tutorial 4. So theoretically this should all load up nicely. I'm just going to bring up my dev tools as well, move that up to a screen up here. Okay, so there's tutorial 4. As I say in every one of my tutorials, just in case you get the wrong impression, the frames per second is based solely on the fact that I have screen cap software running, and that tends to affect it badly. So obviously only 3 entities on screen, you'd expect it to be running at 60 frames per second, and indeed it does if you don't have screen cap software running. So what I'm going to do is I'm going to remove all these little entities from the game first, because we don't want those. It's just there for kind of like a quick base skeleton game, so that you can kind of see how things are operating. So let's just grab this stuff and delete it. All we want is our base scene. I'm also going to go and delete the game textures, we don't need those. And also into the game classes, I'm going to delete all of this stuff. We can keep our CSS, that's fine. Incline config, I'm going to delete the game classes I've just deleted from there as well. So now we have a totally blank game, except for our base scene. I'll save that and reload. So I could think, oh yes, of course, I have the on textures loaded event, which will of course will not fire because we're not loading any textures. So I'm just going to comment that out for the moment. So literally all we're going to do is create a prop buffer and start the engine immediately. We'll load some textures in later and then we'll uncomment those, but for now we'll just leave it as it is. So there's the engine running. As you can see on the scene graph, we have our viewport and a base scene object. These are the ones that are loaded in by adding the IGE base scene graph. So let's go ahead and create an isometric entity. To do that, I'm just going to do it the rough and ready way, just to show you how it works. So I'm just going to do a new IGE entity. I'm going to set the isometric to true. I'm going to give it an ID as well. Usually that's the first thing you do when you create an entity. I mean, you can pass an ID at any point during the initialization or indeed afterwards, but I like to do it at the top because it defines exactly what the entity is called. And I'm just going to call this iso1 underscore container. We'll see why we're going to call it container in a minute, but the general idea is that you have a container entity which is isometrically positioned, and it contains an image entity. So we'll see how that works in a sec. Also, I want to set the size 3D. Now these are the 3D bounds that the cuboid bounds that the isometric system in Isogenic Engine uses to depth sort all of the objects on screen. So the 3D bounds extend to the size of whatever it is you're displaying on screen. I'm going to show you how that works again as well soon, but let me just put 40, 40, 40. So it's a 40 pixel square cube, rather, not a square because we're in 3D. Alright, and then I'm going to mount this, mount to IG.base scene. Again, we're just grabbing the base scene object via its ID, and you can do that with the dollar command .ige.dollar, not to be confused with the jQuery dollar method on which it is somewhat based, but does not require a hash at the front as you would with jQuery, because we're grabbing everything by IDs. So that entity has now been mounted to the base scene. I'm just going to refresh the demo again. Alright, and if we have a look at our scene graph, there's the container now that's mounted to the base scene, as you can see here. Now, as it stands at the moment, when you click an item in the scene graph in here, you'll see that it has output the axis aligned bounding box, and because we're in isometric, it's also outputting the purple lines here, which are the 3D cuboid bounds. Now, we're not mounted to an isometric layer yet, so let me show you how that works, and then you'll see everything displaying in a much more familiar isometric way. So first of all, let's just go ahead and create a new scene. So IG scene 2D. And we're just going to say isometric mounts true. And that basically tells us that any object being mounted to this scene is to be displayed, positioned, depth sorted, etc., all using the isometric algorithm as opposed to 2D. So that's the engine will split off different paths of code execution depending upon whether it's displaying a 2D or an isometric scene. We're also going to mount that to IGE base scene. In fact, because we're calling this twice like that, I may as well just create a variable for it. That way we've stored a reference to the return value rather than calling the method over and over again. It's just slightly better for performance. Now we're going to give our isometric scene an ID, and I'm just going to call it object layer. It doesn't really matter what you call it, but we want to be able to reference it. So let's just create a new variable that we can store that in as well. You'll notice that I tend to declare everything in variables at the top of rather than doing it like this. So I use one composite var call as opposed to multiple var calls. This is just a way of, I think it's cleaner. I think the Douglas Crockford JavaScript standard is similar. Anyway, moving on. So I've mounted that to the base scene. I'm now going to mount my ISO entity to my object layer. So this is mounted to the base scene, and this is mounted to that. And I'm going to refresh the screen again, and you'll see where we're coming from. Okay, and we have to look at this and click ISO container, and there we have an isometric view. So now again, the axis line bounding box. This is the 2D axis line bounding box in blue, and then we have a sort of a 3D looking cube, which is our 40 by 40 by 40. I'm just going to give you a quick kind of demonstration of what it looks like when you increase or decrease one of the bounds. So in this case, I'm going to increase the x bound. So I'm going to make the x bound 80. So it will now be a cuboid rather than a cube, and you should see it extend out in this direction along the red axis line here. So if we go back into here, this is the x. So it's x, y, z, and we're going to do x there. Refresh. Now you'll notice that every time I refresh the screen, I have to go into my scene graph, which is the debug part of the engine, and click on this to get the bounds up. Instead of having to do that every time, I can actually just go and reference IG $VP1.drawBounds true. Now this will automatically draw bounds for all objects on screen. So if we refresh the page again, there we are. So we're seeing draw bounds. So I don't have to keep going into the scene graph now. That draw bounds is, again, it's a debugging feature. It's there for you to use so that you can see the bounds and access line bounding box of all of your entities on screen. Sorry if I seem to be powering through this quickly, but I've got limited time before my daughter goes to sleep this evening, and in fact in 20 minutes, so I want to get this out there and published as quickly as possible for you guys. So this is our isometric container, and it shows the bounds. Now what we want to do, ideally, in an isometric world, is display an image, which is a 2D image, flat 2D PNG, usually with transparency, inside this container so that it's positioned in a three-dimensional way and is depth sorted. So what we're going to do inside this new entity, which I'm going to call ISO 1, and let's just go ahead and declare that variable. Sorry for the video blip just then. The screen cap software kind of did something weird. Right, now I'm going to create another entity which will be mounted to ISO 1, and that will be an image. So what I'm going to do is I'm just going to call it image1 equals new IGE entity, and ID image1 dot mount to ISO 1. Now, we don't have any images loaded yet, or as they are actually called in the engine, textures. So let's go and grab one of those now. Let's see, from the IGE examples assets folder. Okay, so I quite like the bakery. In fact, yes, the church might be a better option because it's a sort of a oblong shape, and it'd be better to sort of display the bounds around an object like that. So I'm going to come back out of that, get into my tutorial 4. I'm going to create a folder called assets, and I'm just going to paste that in there. That's church1.png, as you can see. So now if I go back into my tutorial, let's uncomment this now because we're going to create a texture. Really simple. We've got game texture, which is an array up here. I'm going to turn this into an object instead, so we can name textures. And then we're just going to go game texture dot church1 equals new IGE texture dot, as in our current path, assets church1.png. Okay, that loads our texture into memory. The engine will then wait for textures loaded, which will only fire when all textures that you want to load in memory are loaded fully. So that allows you to kind of make sure that your game doesn't start until the textures are in memory, which is kind of useful, especially for people who are on slower connections, because if the texture's not already in memory, you'll end up with sort of maybe some graphics artifacts while images render or load, and all sorts of things could go wrong. So it's always best to just make sure all your assets are loaded in place first. Alright, so now we're going to assign the texture to this image. So texture equals game texture dot church1. Boom, 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 it's all mounted. Let's give that a quick run and see if I've done anything wrong. Alright, okay, so now you can see our church is kind of small, and you can't really see it, and it's behind the 3D bounds, and the bounds are in the wrong direction. So first thing we're going to do is to just go and give our image a proper size. And the way we do that is entities always start off with default width, height, and length, I guess, of 40, and that's just a standard in the IGE entity class. If you want to, and you've loaded a texture in, after you've specified your texture, you can just say dimensions from texture, and that's it. That will now set the width and height of this entity to the texture we set here. If we do that again, load the page, we should now see a much larger church. Excellent. Okay, so now we have our church in place. Now what I want to do is I want to get the 3D bounds to wrap around that church. So that's relatively simple. We just flip these around. So I think what we probably want is 50 by 90, and the height, that's let me show you that on a mouse. So that's the yellow axis up here. So that goes upwards from 0, which is the floor, at the bottom of that yellow axis there. So probably to get up to that spire, we're probably looking, I don't know, let's say 60, theoretically. And we just go ahead and refresh that again. Alright, so we're not quite there. Let's just make it a little bit larger. Alright, we'll call that 80 by 140 by 100. Okay, we're sort of almost there. I mean, we want to probably align it a little bit better. So what I'm going to do is I'm going to move the image now, because this is an important part of the isometric entity process, is ensuring that the green axis and the yellow axis and the red axis kind of actually match up to your image properly. So images can be translated within their container entity, manually. So what I'm going to do, just to make it a bit easier, is I'm going to open the scene. I'm going to click on our image. Now it looks like the blank game doesn't have the latest CSS, because if it did, we'd have these little buttons here that we could use to translate. So if you just bear with me a second, let me just go into CSS. I have my IGE folder here. By the time you see this video, I will have updated the blank game CSS to make sure it can do this. I'm just going to paste that over the top. Okay. Refresh the page. The buttons I'm talking about were a recent addition to the engine, so here we are. So we've got them here. So I'm going to click on the image. You can click on the container to see the bounds. Basically, we want to get the image bottom corner here down to about here-ish. There are other ways to do it, but I'm just going to show you the manual way first, because it kind of makes sense. And you can see how much we're translating it by here as well. This is a relative from the point it was at to the point it is now. Okay. You'll also notice that now, because I've started the translate already, I've managed to click on the ISO container so I can see its bounds while still having control over the image entity that I was moving. Right, so that's the perfect position. -7 on the X, 30 on the Y. So if you go back into here, we just say translate to -7, 30, 0. Remember, translate needs a Z axis as well, which is 0. When you're dealing with 2D, which you are in the case of this image. So let's refresh and see what's happened here. Hopefully that has now aligned it correctly. Yes. So we now have a properly aligned image. But there is one thing that you'll notice, and that is that our bounds are still larger than our image. So we kind of need to reduce that down a little bit. So that's our y-axis along the green line here. Let's just take our bounds down a bit. So we want this to be, let's say 120. I'm just going to do a bit of trial and error here, refresh a couple of times and see what the system looks like. Yeah, I think that's probably alright. So let's give that a go. Let's move the image. Yeah, I think that's much better aligned. So relative to our current position, it's 2 on the X and 24 on the Y. Okay, and now there we are. We have an isometric entity. It's placed in an isometric container, and it will depth sort. And to show that it will depth sort, what I'm going to do is I'm just going to quickly wrap this into its own class, so we can replicate it. So we're just going to call it church. Okay, so I'm going to grab all of this out of here. I'm going to create. Sorry, I'm going to put that in game classes. I'm going to create a new file. I'm going to call it church1.js. Notice the uppercase C, that's because we're creating a class file. And when you're defining classes, they should always start with an uppercase letter. Church1 equals IGE entity dot extend class ID. Whenever we're extending an existing class, you must provide a class ID which is equal to the variable you've just assigned. So in this case, church1, because we're assigning it to church1 there. So that's the name, that's the ID. Excuse me. In the init method, going to paste in what I had earlier. Now, entity that we're creating is going to be the ISO1 object. So we no longer need to create a new object for this. So instead, what we're going to do is reference this. So we're not creating a new one, we're just name this. We also probably, actually looking at it, I've made a mistake because we need object layer needs to be defined in our client.js. So let's just do that here. Object layer can come out of there. Go into here. Okay. Perfect. So we don't need ISO1 anymore. That's no longer in use. So we just have image1, which is going to be our child image. So texture is that. Now game texture no longer exists either in the context of this class, so we need to reference it somehow. One of the easier ways of doing that would be to just say IGE.client.gameTexture. So IGE.client effectively relates back to our client class. So anything you define in here with this or this.obj for instance, would be accessible. This.gameTexture. So in fact, no, I've said that. We need to do that instead. Okay, that's all good. We have it now in here, textures, blah blah. Translate to mount to ISO1 no longer exists again, so we're just going to mount to this because this is now our church container entity. Theoretically, this should now work if I type new church1 dot mount object layer. So when you create a new class like that, the init method gets called when you call new with the class name. So in here, this is the code that gets executed. So we're referencing our base scene. We're defining an image variable. We're setting a bunch of things on here. We don't really want to set an ID anymore because if you create multiple ones of these, you can't have the same ID. So we're just going to delete that here. We're going to delete that as well. Or if you wanted to, you could do it this way. You could say this.id plus, and that will read the current ID of our class instance, and also add underscore image1 to it. You'll see what that looks like on the scene graph shortly. All right, back to client.js. I've created a church, but at the moment the engine won't know about church1. All we've done is created a file here, but we haven't actually loaded it into memory, and that's where the client config file comes in. So what we're going to do is just going to tell the engine to load that new game class. So game classes church1.js, comma. That should be it. Let's take a quick peek. In theory, this should now look basically exactly the same as it did before. And no, it didn't. I'm getting an error on my console. Base scene is not defined. So look. So I see our object layer is trying to mount base scene, but if you remember, I moved the definition of that out. So I'm just going to grab this, go into client, and just apply it there. Okay, let's give that another go. Object layer is not defined in church1. Yeah, okay. We don't need to mount object layer anymore because this is just going to create the object in memory. If you want to mount it, you do so here, as you can see. So creating church1 should never mount anything to the actual scene graph. It can mount to itself. Okay, sorry about that. I made a mistake in the code up here. So actually we need to do something quite fundamental that I've forgotten to do, and that is call the superclass method init method. So what we do is, because we're extending IGE entity, in our init method we have to call IgEntity.prototype.init.call this. And all that's doing is it's going into the IgE entities init method and calling it with the same context as we're currently in. Because if you have a look into IgE entity, you'll see a bunch of stuff in its init method, which are kind of important for everything we're doing with this. So whenever you're extending a class, you must always call the class's init method, if the class has an init method, in which case, in most cases, it does. Let's try refreshing this again now. All right, okay, we're now up and running, and you can see in the scene graph, I promised I'd show you, the church object has now been given its own ID because we didn't specify one. It's like a random unique ID that the engine will generate for you. And remember we called this ID plus underscore image for the image that's mounted to it, and there you can see the this is the entity that's mounted. This is the 3D bounds of the object it's mounted to. Okay. Now that's great and everything, but let's get a couple more of these on the screen, and you'll be able to see now how the engine will actually depth sort in real time because we're going to move it around. So let's go back to our client.js. Let's just create a couple more of these, but we're going to move them around. So translate to. We're just going to move this along the x-axis for them, so let's just put it 100 pixels ahead. 0, 0. And then 200. And let's see what that looks like. Okay, now as you can see, in fact you probably can't see because the bounds are turned on, but if I switch to the viewport it'll switch them off. They're drawn in the correct order, and that's great, that's exactly what we wanted. So if I now select one of these churches, let's say the one that's behind the others, this one, and I translate it, I'm going to switch back to the viewport now so that we turn off the bounds so you can see how this all works. Sorry, let's just refresh that quickly. Get to the church, click translate, go back to the viewport. Alright, so we can now move this object around. Now, as we move it around, theoretically you should see it's depth sorted correctly. It's now depth sorting in front of that object. If we move it like this, it'll pop behind because the bounds are now intersecting. And that's 3D depth sorting working for you right there. Kind of cool, huh? Anyway, that ends the tutorial for the moment. That's just getting some basic isometric entities on screen. We'll discuss, I guess, in another tutorial the how tile maps work. So, I mean, this is positioning stuff in an absolute way at the moment. So there are no tiles backing any of this up, and the engine allows you to position arbitrarily if you wish to, or alternatively you can actually position on tiles, which I think is quite useful for isometric games in general. And kind of tends to kind of fit with what everyone else is doing on the web at the moment anyway. So anyway, thanks for listening. Sorry if I went a bit fast there, or if I waffled on a bit, or if there were some blips with the video. I had some problems with the screen cap software as it was running. It cut off a couple of times, so there might be some disjoints in the video as well. But please keep tuning in, and don't forget to subscribe. Cheers, bye-bye.